So let's talk about the basic integration rules. So basic integration rules uh, that we have here. Power rule is going to be a big one for us. So the integral of x to the n dx is equal to x to the n plus 1 over n plus 1. And then this is a indefinite integral, so plus c. This is kind of like the most common one that we're going to probably be using for a little bit. Um, and by a little bit, I mean not that little of a bit, because we're going to be doing some other integration things. But power rule ends up showing up a lot. The integral of a constant, which we have now kind of done, which is the integral of k times dx, so a number times dx. That's whatever our number is times x plus c, where k is a constant. One really big one that's really helpful is the scalar multiple property, which just says if we have some integral of a number times a function that we're trying to take the integral of, that's the exact same thing as taking that constant and multiplying it by the integral of just the function. From here, we have kind of like our big integration rules. So for instance, e to the x, if we take the derivative of e to the x, it is e to the x power. But one of the things that we're going to see a little bit more often is u. So I'm going to write these as u's with du because it's going to be important for later. So if we see e to the u and it's with respect to du, that's like e to the x. And we know the derivative of e to the x is e to the x, so we know that the integral of it is going to be the same, just with a plus c. This means if I have the integral of something that's not e to the power of x or to the power of u, we're going to have a to the power of u, we're going to have r plus c, but then that multiple of the natural log of whatever our base is, a, we want to divide by it this time instead of multiplying it because we want to account for this missing constant. And we're going to talk a lot about missing constants when we do a little bit more with integrals. Okay, so I alluded at this earlier, n to the negative first power, or 1 over x. I meant x to the negative first power, but either way, 1 over u or 1 over x. When we take the derivative of something specific to get to 1 over u or 1 over x, that happens to be the natural log. The one thing that we want to make sure is that we can't have negatives in our natural log function, so we want to take the absolute value of whatever is in the denominator and add c. If we go backwards for all of our trig functions, sine's integral is cosine, but if I take the derivative of cosine, we have an extra negative in here, so the integral of sine happens to be negative cosine. If we take the integral of cosine, that's going to give us sine, because if I take the integral or derivative of sine, that would have given us cosine. The integral of secant squared is something that we can do because the derivative of tangent is secant squared, so I know that that backwards is going to kind of help us out. That means cosecant squared's antiderivative is going to be negative cotangent. Okay, then we got that last one. Secant u times tangent u, or tangent u secant u, is going to be our antiderivative of secant. Cosecant u times cotangent u is negative cosecant plus c. So these ones are more of just, do we know what the derivative of those things are, and can we kind of work backwards? The ones that are a little bit more annoying are those inverse trigs. So we only care about 3 inverse trig problems. So we have 1 over the square root of a squared minus u squared. This format is going to be sine inverse. So we have sine inverse of u over a plus c. A being any number that's squared, u being any x that we end up having. If we have 1 over a squared plus u squared, or u squared plus a squared, so some number squared plus our x value squared, this is tangent inverse. But we have 1 over a tangent inverse of u over a plus c. And then the last one that we're going to be talking about is the integral of 1 over u square root of u squared minus a squared. So 1 over x times the square root of x squared minus some number squared du. This is secant inverse. So we have 1 over a secant inverse of absolute value of u divided by a plus c. So those last 3 are the only ones that are like what, even though it's part of the basic integrals, is not really necessarily basic. It's just kind of a lot. But we only need to know 3 of them, because if we add a negative in there, we can just add in that negative to our answer, and then we're done.